But because of that, when you draw in your diagonals on a rectangle, you form right triangles, and then you can use the properties of right triangles we talked about in Chapter 5. Okay, so one of the things that you want to be really careful of, and this is for all of Chapter 6, is when they don't give you the diagram, but they give you the name of your polygon, or your quadrilateral, make sure that you understand it has to go in consecutive order. Okay, clockwise or counterclockwise is fine. Everything's relative, okay, but it needs to be a consecutive order. So if you are given a KLMN, so you can start wherever you want. Okay, I can go the counterclockwise KLM, I could have done it in any way, but you can't just go KM or KLMN. You can't zigzag across. It has to be consecutive along the quadrilateral. Okay, and then it says when you draw in your diagonals, the diagonals are going to intersect at point P. And so you get the diagram yourself, and you might have to create that. If you then label what you have, PN is 16 and KL is 15. And it's asking you to identify the measure of angle LKM. So here is the angle that you're trying to find. Okay, what I'm going to do as I set this up is I'm going to pull the triangle out that I'm going to use to find my angle. So I'm going to pull out triangle LKM right here, so I can see exactly what it is that I need to. Well, this whole length KP, or K to M here, this whole diagonal across the rectangle, okay, if I know that KL is 15, I can find what this whole diagonal is, which is the hypotenuse of my right triangle, because the diagonals of a rectangle, because it's a parallelogram, bisect each other. So if this is 16, that means this is also 16. And then the diagonals of a rectangle are equal to each other. That was one of the properties. So if this whole length is 2/16 or 32, that means this length is also 32. So once you find that, you can now calculate your measure. We want to find LKM, which is this angle right here. Okay, so I'm going to go ahead and label this theta. And so with respect to my angle theta, I have an adjacent leg and a hypotenuse. Adjacent and hypotenuse are related by which trig ratio? Cosine. So I know that the cosine of theta is equal to adjacent over hypotenuse. So theta itself is going to be the inverse cosine of that ratio. And I can go ahead and calculate that. Inverse cosine of my ratio, 15 over 32. I'll put a decimal in here so my answer is displayed as a decimal. And when I do, I get my answer of 62.05 approximately. The measure, or the unit, is degrees. And so this gives me the calculation that I'm looking for.